Hi, I'm Neil Dixon. Welcome to this tutorial on assembly language. Through learning basic assembly language, this tutorial is designed to give you a better idea of how software you write actually works under the hood. I found that this knowledge can be very useful for designing and implementing efficient software, as well as for understanding what is and isn't feasible, since there really is no magic in software. Assembly can be a bit daunting conceptually, so I've tried to make this as simple as possible. I'm assuming that you have some programming experience, preferably some C or C++. I wouldn't recommend assembly language as a first programming language, as higher-level concepts can be difficult to learn or implement in assembly. I will be making tutorials later on dealing with more advanced topics, ranging from code optimization and software-based 3D rendering to operating system development, partly depending on what people are interested in learning. Later in this tutorial, you'll need some software I'll mention when they're needed, but this video just introduces some basic concepts, so you won't need anything special. So first of all, what have we got in our computer? Well, from the CPU's perspective, there are really just three things: itself, RAM, and I/O, or devices. I/O is a complex beast, so this tutorial will just focus on the CPU and RAM. Usually I/O is left for the operating system to manage, so one would call pre-made libraries to do I/O. There's still no magic involved with it, but it requires much more explanation. Memory at its core is pretty simple, so let's start there. You've got a chunk of RAM, let's say 4 gigabytes. Now RAM is split up into bytes, 8 bits, and each byte has an address indicating its location in memory. In 32-bit mode, this address is a 32-bit unsigned integer. In 64-bit mode, it's a 64-bit unsigned integer. We'll be using 32-bit mode in this tutorial, since not everyone is running a 64-bit operating system yet. Addresses are easiest to write in hexadecimal, which I'll denote with an H at the end. The only major concept to understand about memory before moving on is ironically that there is nothing special about it. This may be painfully obvious to some, but if you use memory to represent characters in strings, then that's what's there. If you use 4 bytes as a floating point value, then that's what's in those 4 bytes. Memory can be used to hold colors, pointers, data structures, and it even holds your code in a form known as machine code. The thing to realize is that in the end it's all just bytes, and the meaning of those bytes only exists in terms of how you use them. Okay, so that was really all there is to know about RAM at the moment, so we can move on to the CPU. The CPU's main job is executing code, but as I just mentioned, the code is in memory, and it's encoded as machine code. Don't worry too much about memorizing the stuff on this slide, just try to understand what's going on. Real CPU execution can get much more complicated, but the concept is the same. First, the CPU needs to actually retrieve the machine code from RAM. Then it needs to figure out what instruction is represented by the machine code. This includes determining what operation is to be done, and what data, known as operands, the operation will be done on. Once it knows what data are needed, the CPU has to get them from RAM, or from what are called registers, something I'll explain in a moment. Now it has all of the information it needs to perform the operation, so it goes ahead and does it. The operation is finally done now, but the results of the operation just need to get stored somewhere, so they aren't lost. Knowing this won't necessarily affect the code you write, unless you get into advanced optimization. But it shows how even in the CPU there's really no magic. As I said before, the concept is more important than the details on this slide. I mentioned registers back a bit. These are variables that are built into the CPU. Yes, there is some information kept on the CPU instead of in RAM, partly because it's relatively slow for the CPU to get data from RAM. So let's take a look at what's inside the CPU. Now don't worry, most of these are things you only need to know about for advanced topics, so we'll just ignore them and focus on what really matters here. That's better. In 32-bit mode, there are 8 32-bit registers that you can use directly, referring to them by their somewhat arbitrary names. These are called general-purpose registers, or just general registers, although some of them have a few special purposes you'll learn about in later videos. These 4-byte registers also each contain a 2-byte register, and the first 4 of those 2-byte registers are further split into 1-byte registers. This is a bit easier to see by example, so I'll leave that for later. There's also a set of condition flags indicating some properties of the last result calculated, and the instruction pointer, which holds the address of the next instruction to be executed. Okay, enough hardware. What on earth is assembly language? It's simply a text representation of machine code. That's all, nothing special. It's the lowest level software programming language. So why would we want to use this language? For this tutorial, the most important reason is to understand how software really runs on the CPU. There are a few other reasons, and they all come down to control. Unfortunately, compilers aren't perfect, and it's even possible to formally prove that they can't be perfect in all cases. In some cases, they are far from perfect, so significant performance gains can be made by using assembly language, though this takes a lot of skill and experience. I'll probably make a tutorial on optimization like that later, but it's an advanced topic. Some things that need to be done in operating systems and embedded systems turn out not to be possible in C code alone, so assembly language is needed for those operations. Overall, assembly language isn't used often in production software, but it is important where it is used. In the next video, we'll be getting right into it, filling an image with color, believe it or not. Thanks for watching.